I've been in networking for over a decade and decided to make some content to try to help others understand this industry. Charles Boole was an English mathematician and came up with different types of logic that's called Boolean logic, named after him. So, one piece of this is the AND gate, and we use this in electronic circuits. And we're going to talk about how this works and focus in on this because it really helps in understanding what's happening behind the scenes when you have to have a subnet mask and an IP address and you get network IDs and subnets. The AND gate is critical for that. So this is the symbol for it here. It kind of looks like a plug. And the way it works is you have two inputs, input A and input B, and you have one output, which is X. Now, Boolean logic uses a truth table that basically says the different values of what A and B could be to result in the value of X. So we're going to set this up and look at all these combinations. And these usually are represented as true and false. So your input is going to be either true or false, and then your output will be true or false. So here's what a truth table looks like. And these are the different combinations. So column A represents the different values that A could be. Column B represents the different values that B could be. And then in column X, we see what the output of that would be when you put that through an AND gate. So the first combination would be if input A is false and input B is false. So we're going to put F's there to represent that. Then the output X is going to be false. So if A is false and B is false, then X is false. The next combination will be if A is false and B is true. At this point, X is also false. The next combination would be as A if true and B is false, then X is going to be false. And then the last combination here is if A and B are both true, then X is true. So here's the full truth table here. And you can see that the only combination that results in a true is if A and B are both true. So A and B have to be true in order for X to be true. So this is just a logic table. Now we're going to see how it applies to digital circuitry. So instead of having false, we're going to say false is actually going to be 0. And then instead of saying true, we're going to say true is equal to 1. Well, now what we have is a logic table here with zeros and ones that can be used in binary. And now this AND gate can be used to compare two different bits to result in a different bit. So in this situation, if A and B are both ones, that is the only time where you would have an output of 1, where X would be equal to 1. And so this type of logic is used when we start dealing with subnetting and figuring out what network IDs are and really start using the subnet mask.